All right, so outside of stability, I mean, we went through some stability notions and some examples um, showing sufficient conditions for proving asymptotic stability. But what else can we do with linear time invariant systems or just state space systems in general? Um, well, so I'm titling this Beyond Stability. Um, so there's many special properties that you can look at through either control, where you're trying to get the state to go to a certain position, or if you have an output, not the state directly, how do you actually estimate what the state is through those measurements? So some properties that people look at that are interesting for systems with direct control. Is one is the notion of reachability. Right. So reachability is defined as for fixed values of the initial time, t naught, and the final time, tf. A reachable set or region is defined as the envelope of final values that can be achieved, be reached from an initial point and through control. So this looks like, let's see if I can draw it here. So if we have a starting position here and a final position here, a reachable set is a set that if I can define a control UI that takes you from this initial condition T naught to this final condition TF. All right, so that's reachability. Next is controllability. Let's see. Controllability. So for fixed, again, for fixed values of the initial state or the initial time and the final time, a controllable region is defined as the envelope of x dot from which the final state can be reached through control. So note that this one looks at the final time, the set of the final states here, the difference between reachability and controllability is that reachability looks at the set of final times or final states at the final time, whereas controllability looks at the set of initial points to take you to that final point. So if I were to draw this a little more succinctly here, let's see. I'm going to augment this final time, and then I have this final point. And then, I mean, in general, you can expand this point to be a larger region and then look at how that region evolves. But for the sake of this definition, so we have this final point, and then we look at if this set is reachable, then I can craft an input that takes me from here to somewhere in this envelope. Whereas for controllability, I have this set here. This is x of t naught. And then I have a final point here. So this is x at tf. And so then if the system is controllable, then I can take from any initial condition, x naught, into this final condition through a control input. And one of the last things that, I mean, we talked about it a little bit, at least gave an example, is this idea of stabilizability. Spell that right. Why? So stabilizability is a system is stabilizable if there is a control history u of t such that the limit as t goes to infinity of x of t is equal to x sub f. So a system is stabilizable if we can show that the state converges to that final state that we're interested in. Some other things that people are interested in, if we only can measure the system, so we can say you have a car that's driving, but you can only measure it from an outside position in the car. So if we have, say we have a car driving this way, but for some reason, or maybe a police officer is trying to get your speed, right, to give you a ticket. So we can only measure you from this point, and you can measure only the range here and maybe the angular velocity here. Okay, so now these are the measurements that you would use to input into your estimator to give you to estimate your state. Okay, so let's see if I can make this a little more clear. So car, police, measured values are the range, r is equal to the range, and the angular rate. Right. So, let's see here. So for properties, of systems with measurements, one property that people look at is this idea of constructibility. And these will be very similar to, the definitions will be very similar to the definitions for controllability and reachability. But for constructibility, where you'll see a lot of similarities. So for fixed initial time and final time, a controllable, a constructible, see there I go, region is the envelope or set of points that can be determined from the output, y of t, inside this interval. Okay. Next notion is this notion of observability. So for this one, again, for fixed values, for fixed initial time and final time, an observable region is the envelope of initial points, initial conditions that can be determined maybe I should spell determined from the output signal, again, in this interval, T naught to TF. Great. And the last one is this notion of detectability. So detectability is the ability to identify unstable modes of a system. So now these definitions here are very high level in general. So they apply to both linear and nonlinear systems, time invariant systems, state space systems. And so the crux of it is, so you can use these for all of them. But for linear systems in particular, so for linear systems, it follows that we can say that a set is reachable if and only if it is controllable. And this should be, I think this should be for LTI, for linear time invariant systems. And then constructibility implies in both direction observability. So for linear time systems, if we can show that a system is observable, then we can show that it's constructible. If a system or set is controllable, then it's also reachable. And now this is only true for linear time invariant systems. So next I'll talk about controllability and then observability and give some examples.